Assalamualaikum. We are from Group 5, Session 1. We would like to present about the lab report, which is Leveling Work. I am Fatin Huda. I will introduce my group members: Khairul Firdaus, Lo Jingwei, Muhammad Fitri, Nurul Atira, Tay Chen Chong, and Cho Min Lee. Instrument that we use on this lab is automatic level, staff bubble, optical plummet, tripod, staff or pole, arrow, measuring tape. We will start present about Lab 1. Objective for Lab 1 first is to enhance student knowledge in leveling procedure. Number 2, to measure the height and flatness of the ground. Number 3, to provide people the chance to practice setting up and using the auto level firsthand. The last one is number 4, to assess the leveling acceptability by determining the misclosure error.
Okay, I will continue with procedure of leveling lab 1. Firstly, we prepare all the necessary equipment to do the leveling process. The important equipment that we use in this lab is optical plummet, tripod, automatic level, and staff. And then we setting up the leveling instrument at setup 1. The staff we place on the first benchmark, and the position has been redetermined. First staff we put at BM, and the second staff we put at TP1, and then the tripod was placed at 50 feet away from the staff, and then after we put the staff and the tripod, we take a first reading a tripod with a correct and accurate reading method. Okay, after we take a reading, we take a note in the first data. We move to the staff to TP1 and take a reading. This will be front side, because after this reading, the setup will be moved. After that, we set up the level at setup 2 and leave the staff at TP1 on the exchange plate. The staff is turned to face the level and we read. This will be a situation backside view. After we take a front side, we take a backside data. And then we move the staff to TP2 and read again the data, and this will be front side. After that, after we take a record from the setup 1 and setup 2, backside and front side, we move to the level at level setup 3, and then we repeat the same thing. We move the staff to front, and the first staff will be backside, and the another staff we move will be the front side. And after that, we read the record from backside and front side, and then we repeat all the things, same step until setup time. Okay, for the calculation in this lab, we just need to find the rise and fall after we get the backside and front side data. Okay, we have a 10 setup, and we put all the data backside and front side here. And then for the calculation and formula rise and fall, the formula is backside minus front side. So we will get the answer. If the answer is in negative, the data we will assume that that is fall. And if the answer in positive, the answer is in rise. For example, setup 2, we need to find whether the line is rise or fall. So we calculate the equations. The backside is 1.305 minus 1.445 equal to negative 0.14. So the answer in negative, so that will be fall, because the answer in negative. Another example, in setup 3, the backside is 1.445, and the minus to front side 1.435 equal to minus 1.435 equal to 0.01. So the answer in positive, so that will be rise. because the answer in positive. So the equation will be continue until 10, until setup 10. If the answer in positive we put as rise, and the answer in negative we put in fall. Thank you. That's all from lab 1.
Okay, I will continue the presentation about lab 2. Okay, objective. We have 4 objectives for lab 2. For the first one, to enhance student knowledge in leveling procedures. Next, to measure the height and flatness of the ground. Next, to enable students to get hands-on experience in setting up and working with the outer level. And lastly, to identify the position point intermediate site.
Right now, I want to present about field data in lab 2. On the right side, it shows the formula BS minus FS, and we will get rise and fall. So, for example, 1.312 minus 1.420, and we will get 0.1084 fall. And for rise, we will minus 1.420 minus 1.285, and we will get 0.135. And another one, 1.285 minus 1.265, and we will get 0.02. Alright, now I want to present about procedure of leveling with intermediate sites. First of all, prepare all the necessary equipment to do leveling process and ensure that the equipment work properly. Next, setting up the leveling instrument at setup 1. The staff is placed on the first benchmark at the position that has been determined by the group members. Then the tripod was placed 50 feet away from the staff. The staff is held to the group members in the right way so as not to prevent data reading on the staff. Next, the first reading is taken through a tripod with a correct and accurate reading method. This is bedside because it is the first staff reading after the instrument of the leveling has been set up. Move the staff to TPI and take the reading. This will be foresight because after this reading, the setup will be moved. The distance between stations must be measured and recorded in a record to make a report later. Next, then when the BS and FS readings are taken, the intermediate size record will be taken by placing the staff between the BS and FS. The position of IS, which is between BS and FS, is determined by group members with a distance that is not too close and not too far from the view of BS and FS. Next, set up the level at setup 2 and leave the staff at TPI on the exchange plate. The staff is turned to face the level and read. Then it is in the situation bedside view. Move the staff to TP2 and read again. This will be it foresight. And the last one, repeat the step that describe until finish at setup 6 for record the FS and BS data, and repeat step G and H to record IS data and finish at the last benchmark at the datum bank.
Now I want to talk lab work 3. The objective to do the lab work 3 is to prepare the land of construction by adjusting the topography. The surveyor helps create a suitable surface for buildings, roads, or other infrastructure. To achieve the desired grading and leveling of the land to ensure that the surface has the necessary slope and contour to meet engineering specifications and functional requirements. To establish appropriate slopes and contours that facilitate the natural flow of water away from structure and prevent water accumulation. Surveyors calculate the volume of material to be cut or filled during earthwork operations for estimating costs, planning material transportation, and ensure that the project stays within the design budget and time frame. Now we look the field data, rise and fall method. The right side is the formula will be used to find the data. The initial data of reduced level is 1.501. How we can get the data like this, like 1.561? We can use 1.501 to add 0.06. It will become to 1.561. For other example, how we can get the data 1.511? We can take the 1.716 to subtract 0.205. It will equal 1.511. Now we look procedures of leveling. First is to prepare all the necessary equipment to perform the leveling process and ensure that the equipment works properly. Setting up the leveling instruments at the first benchmark BM, the staff is placed on the BM at the position that has been determined by the group members. The first benchmark between the staff is 10 meters. Next, the staff is held by the group members in the right way so as not to prevent data reading on the staff. The first reading is taken through a tripod with a correct and accurate reading method. This is the backside BS because it is the first staff reading after the instruments of the leveling has been set up. Move the staff to IS1 and take a reading. This will be a foresight FS because after these readings, the setup will be moved. Repeat the steps that describe IS2 to IS5 until finish at the last benchmark at the datum back.
Good morning to doctor. My name is Tae Cho. I will present the lab for task 1 and task 2. For the task 1, we will calculate the height of convection, which is half of C, by using the BM of 1.223 meters as starting point. The formula of height of convection which equal to reduction level plus backside. After we get the first height of convection, we will deduct the intermediate side and the fourth side. For example, the calculation of step 1, we are using the first starting point, which is 1.23 meters, plus the 1.312 for the backside. We will get the answer, which is 2.645 of the height of combination. After we get the height of combination answers, we will minus the IS, which is 1.420. And the next calculation, we're using the same formulas. For the lab for task 2 of rise and fall method, we will calculate the reduction level by using the starting point at 2.333 meters. First of all, to calculate the reducted level, we will calculate the rise and fall. To calculate the rise and fall, we will using the backside and intermediate side. When backside minus intermediate side is positive, we will put the number in the rise. When the backside minus intermediate side is negative, we are putting in 4. To calculate the reduction level, we are using the starting point minus or plus the rise of force to calculate the reduction level. For example, the calculation in step 2, we're using the starting point at 2.33 meters plus 0.06. We'll get the answer with 2.393. We are using the plus because the answer is right and is positive. When at the step 6, we are using the minus because the data is 4, which is 2.473 at the reduction level, minus the fourth 0.04, we'll get the answer with 2.433 meters. For the height of accumulation method, we'll calculate the height of accumulation by using the first of VM, 2.333 meters as starting point. The formula of height of accumulation is the reduction level plus xi. We are getting the first data of the height of accumulation, then we might deduct of the intermediate size, which is is, or the fault size. The example calculation in step 2 is showing the data of the first of collimation 3.753 minus the IS, which is 1.3060. We're getting the data 2.393 for the second reduction level. The next calculation, we're using the same formula to getting the reduction level. Thank you.
Good morning to Dr. M.L. Jim Wei. Now I want to present the Lab 5, which the task is using the data from our Lab report 4 in task 2 to proceed with the calculation. The formula for the height of instrument is the spot height plus the formation, and the product equal to the height of instrument times the norm of square. The formation for the construction is 1.05. For example A, the spot height equal to the 2.333 minus the formation, which is 1.05, equal to the height of instrument, which is 1.283, and times the norm of square, which is 1, equal to the product 1.283. And the mean is the total of the product divided by 4, because the square has 4 sides. So, which is the 23.02 divided by 4 equal to 5.755, and the volume equal to the cross-sectional area of one prism multiplied by mean height of grid, which is the volume equal to 10 times 10 times 5.755 equal to 575.5 CUM. So